Saturn V Quarterly Film Report Number 9 covers progress during the period December 1st, 1964 through February 28, 1965. Development, manufacturing, and testing of S-1C stage components by the Boeing Company and the Marshall Center continued throughout the quarter. At Marshall, the first S-1CT horizontal assembly operation began early in December. The thrust structure fuel tank assembly for the S-1CT static firing stage was transferred to the assembly area from the vertical assembly building and was mated on December 18th to the forward skirt LOX tank inter-tank assembly, which had been moved from the VAB last quarter. Cable installation and other miscellaneous mechanical assembly work continued during the report period. In early February, a dummy F-1 engine was installed on the S-1CT vehicle to check out various fittings and connections. The operation went so smoothly that the engine was installed, fittings checked, and the engine removed, all within 4 hours. At the end of the quarter, the Saturn V program reached one of its most significant milestones when the S-1CT was installed at Marshall's new S-1C static test stand for the first S-1C stage single-engine test firing expected in early April. Notable progress in the manufacture of assemblies for S-1CS structural test components was made this quarter with completion and hydrostatic testing of the LOX tank and mating of the fuel tank to the thrust structure which had arrived at Marshall from Michoud in late December. Meanwhile, the Marshall Center's new load test tower was placed in operation in February when structural testing got underway on the first intertank for the S-1CS program. Maximum aerodynamic loads expected in flight were simulated by 2 load rings and a bootstrap arrangement of hydraulic cylinders, tension straps, and load cells. The intertank buckled at 110% of the axial load and 117% of the moment load. Since a 140% factor is required in all man-rated Saturn V hardware, a strengthened intertank built at Michoud will later undergo similar testing. Following removal of the intertank, the S-1CS fuel tank thrust structure assembly was installed in the load test tower. Structural testing of this assembly is scheduled next quarter. Meanwhile, bulkhead fabrication progressed steadily on the first 2 S-1C flight stages, S-1C1 and S-1C2. Another bulkhead for the S-1CF facilities checkout stage, LOX tank, was finished in early February and shipped to Michoud. Cylindrical skin assembly for the S-1C1 LOX tank was also underway. At Michoud, the new vertical assembly building became operational in January. Initial use of the VAB was in assembly of the fuel tank for the S-1CD, or dynamic test stage, when the fuel tank forward bulkhead and skin ring were mated. On February 24th, the forward and aft assemblies were joined to form the S-1CD fuel tank. The exclusion riser was installed on the S-1CD lower fuel tank bulkhead. Purpose of the exclusion riser is to occupy space in the bottom of the tank which would otherwise hold fuel that would never be used. The displacement of this fuel by the exclusion riser results in a weight saving of some 5,000 pounds. Bulkhead fabrication for S-1CD was concluded in January with completion of the lower LOX bulkhead. Fuel tank bulkhead assembly for the S-1CF facilities checkout stage began in January. Several major components were shipped by barge to the Marshall Center during the report period, including the thrust structure and forward skirt for the structural test stage and the thrust structure for the first flight stage. Other components being manufactured by Boeing Michoud included the first of 4 fins for the structural test stage and upper fairing frame assemblies which attach to the thrust structure. The Electro Development Corporation of Seattle, Washington, which manufactures various electronic components for telemetry systems, is representative of the 2,500 companies which keep supply lines of components and sub-assemblies moving on schedule to Boeing Michoud from all over the United States. The Brown Engineering Company of Huntsville, Alabama, also manufactures telemetry equipment. Another typical Boeing supplier, Bournes Incorporated of Riverside, California, makes some of the smallest pressure transducers, 7/10 of a cubic inch in size, used in the S-1C stage. At the S2 static test facility at Santa Susana, a successful single-engine main stage firing of 9.8 seconds duration on December 11th highlighted activity at the battleship test stand. The test marked the first occasion in which the J2 engine had been fully fired as an integral component of the S2 propulsion system. Now that the single-engine test program is completed, all battleship effort is being directed toward activation for cluster firing. All J2 engines, as well as all GSE or systems development devices, have been received at Santa Susana. A preliminary system checkout of the J2 engine gimbal actuation system installed in the S2 electromechanical mock-up was performed this quarter at Downey by the S2 prime contractor, North American Aviation's Space and Information Systems Division. In the GSE checkout and test area of the electromechanical mock-up facility, checkout of control room GSE racks is expected to be completed in March. The control room contains a computer complex, a telemetry checkout station, RF station, electrical checkout station, and digital data checkout station. The major subcontractor effort for delivery of GSE for the electromechanical mock-up is being accomplished by Brown Engineering Company of Huntsville, Consolidated Electrodynamics Corporation of Pasadena, and Computer Data Corporation of Minneapolis. An S2 program milestone was reached on February 1st with completion of the structural test stage at S&ID's Seal Beach facility. Primary aims of the structural test program will be to certify the structural integrity of the complete stage when subjected to critical design loads and simulated temperature environments, and to determine the stiffness of the thrust structure. The stage was removed from the vertical assembly building on February 2nd. The stage was lifted and rotated to a horizontal position for loading on the stage transporter, which hauled it to the structural test tower for installation there. Fabrication of jigs and fixtures required for structural testing is complete, and instrumentation of stage and tower is progressing toward the scheduled start of testing in April. After testing, the stage will be modified to a dynamic stage configuration, deleted during a recent reprogramming, and is slated for delivery to Marshall in November for dynamic testing. Also at Seal Beach, fabrication of the S2 common bulkhead test tank was highlighted by completion and ultrasonic inspection using dye-penetrant solution of the common bulkhead, and by circumferential welding of liquid hydrogen tank cylinders number 1 and number 2. Welding of the common bulkhead and LH2 bulkhead to the cylinder assembly was also completed. Construction of the common bulkhead test tank facility at Santa Susana was completed in February. The CBTT test article is scheduled to be received at Santa Susana in April. Final assembly of the all-systems stage was begun in February, the first operation being the welding of cylinder number 3 to number 4. Cylinder number 5 was later welded to 3 and 4. All major structural components, such as bulkheads and thrust structure, necessary for vertical assembly of the all-systems stage, are scheduled for completion by the end of March. Assembly of major structural components is also in progress at Seal Beach for the facility's checkout stage. Final assembly will begin next quarter. At S&ID's Tulsa facility, manufacture of components continued for the first 2 flight stages. A ceremony at Douglas Aircraft Company's Huntington Beach, California facility early in December marked the formal turnover to NASA of the first S4B stage built by the company. The stage, designated S4BD, was then shipped from the West Coast to the Marshall Center for use in Saturn 1B and Saturn V dynamic test programs. At Marshall, the stage was installed in the Saturn 1B dynamic test stand in mid-January as part of the Saturn 1B vehicle. Meanwhile, back at Huntington Beach, after completion of checkout and painting of the facility's checkout stage, S4BF, the stage was moved to Douglas Sacramento test area. On February 18th, the stage was installed in beta test stand number 3 for propellant loading tests scheduled next quarter. Fabrication and assembly of components for the first and second S4B flight stages for the Saturn V program continued at Douglas Santa Monica plant. Also in progress during the report period was Douglas' structural test program involving various S4B components, such as this static test thrust structure. Another item undergoing qualification testing was this liquid oxygen tank assembly. And an S4B forward skirt was tested to failure to determine maximum load conditions. At the Sacramento test area, the S4B battleship firing test program continued during December, with successful firings varying from 10 seconds to 416 seconds in duration. The 416-second firing was the longest S4B test to date. In late January, J-2 engine number 2003 was removed from the battleship test stand and was replaced with engine number 2013, which has a gimbal capability for the continuation of tests. In addition to hot firings, such development tests as engine chill down and propellant utilization were also conducted. Rocketdyne's F-1 engine flight rating test program, which began November 16, 1964, at the Edwards Rocket Engine Test Site in California, was successfully concluded on December 16th. Engine number 2004, installed in test stand A1, was utilized in the safety limits series of tests, while engine number 2006, installed in stand 1D, was used for the calibration series. At the high-flow water facility, a new flow collection system has been installed to provide an accurate means of measuring the volume of flow through selected orifice groups. This data will be used in the development of injectors with improved performance. Rocketdyne is conducting qualification tests on a number of F-1 components. The heat exchanger check valve, which prevents LOX from the propellant tank from entering the system during standby, was installed on the 15-ton shaker for vibration testing. The flight combustion monitor has undergone a number of tests, including function testing to determine frequency response, amplitude, and time delay. Several types of F-1 engine insulation fastener samples have been subjected to stress tests to determine fastener size and spacing. Structural integrity of the F-1 electrical interface panel has been successfully proved in a series of tests, in which the panel was loaded along three principal axes. At the Marshall Center, propulsion system testing of 3 of the 5 F-1 engines for the S-1C static firing stage has been accomplished. Test completion is expected by the middle of March. At Marshall's new F-1 static test stand, interior work continued in preparation for initial engine testing scheduled for April. A milestone of vital importance to the entire Saturn Apollo program was reached on December 9th, when Rocketdyne's J-2 engine successfully demonstrated its ability to stop and restart in a static firing conducted at Santa Susana. The test engine was operated initially for 165 seconds and shut down. Following a 75-minute simulated coast period, the engine was restarted. The restart was cut off at 7 seconds because of an erroneous helium pressure reading. After 6 minutes, the engine was started again and run for 310 seconds, simulating the S-4B stage in flight. Following successful completion last quarter of J-2 engine preliminary flight rating tests, the test engine was removed from the stand and completely disassembled for a teardown inspection at Rocketdyne's Canoga Park plant to determine the extent of wear on the engine after 18 firings totaling 2,350 seconds. On January 22nd, acceptance testing of the first J-2 flight configuration engine was conducted at Santa Susana, and on January 26th, the engine was delivered to Douglas for use in its S-4B battleship program. Also at Santa Susana, major modification of vertical test stand number 3 has been completed to provide improved propellant conditioning and increased overall utility. Vibration testing of the instrument unit designated as SIU-200V got underway in late February. The tests are being conducted for Marshall by the Wiley Laboratories in Huntsville. Although the 200V unit testing is actually a part of the Saturn 1B program, Information gained will apply also to the Saturn V program. Assembly of the Dynamic Test Instrument Unit SIU 200D-500D was completed February 1st at Marshall, with installation of dummy equipment. The unit is for use in both the Saturn 1B and 5 programs. Assembly of SIU 200S-500S, a structural test unit, was finished in late February. The dynamic test unit was later installed atop the S4B dynamic test stage in Marshall's Saturn 1B dynamic test stand, where it underwent testing as part of the Saturn 1B vehicle. Structural buildup of the 500FS Flight Systems Instrument Unit began in mid-February. This unit will be shipped to Douglas next fall for use in testing there. Assembly of the Facilities Checkout Unit 500F continued. It will be sent to Cape Kennedy in June. A breadboard version of the IU's launch vehicle digital computer used in guidance operations has been received at Marshall from the manufacturer, International Business Machines, and is now being checked out and evaluated. The first of the several prototype computers will be delivered next quarter. At IBM's Huntsville facility, the first major piece of hard tooling for use in IU assembly, a structural assembly fixture, was received and installed early in the quarter. Installation, calibration, and checkout of one of IBM's 2 telemetry ground stations was also accomplished. At IBM's Space Guidance Center in Owego, New York, radiographic inspection was accomplished on the first piece of production hardware to enter the company's production cycle, a magnesium casting which forms the base assembly for SIU 201's Emergency Detection System distributor. Other machining operations underway at Owego included a casting to be used in the launch vehicle data adapter, a component of the guidance and control system. At the Marshall Center's Saturn V ground support equipment test facility, installation of technical systems has been finished and checkout is now nearing completion. Buildup of the facility's vehicle motion simulator by the prime contractor, American Machine and Foundry Company, is approximately 25% complete. A new landmark arose at Marshall as the 120-foot-tall acceleration test and calibration facility took shape. The facility will contain a large centrifuge, an acceleration tower, and an acoustical chamber for testing guidance components. At Marshall's Mississippi test facility, the first of 3 static test stands towered more than 100 feet above its foundation by the end of the quarter. This stand, nearest completion, is for the S2 stage. In MTF's test complex, work also progressed on a second S2 stand and on the dual-position S1C static test stand. In other areas of MTF, buildings such as the office and administration building were completed, while others took form, so that the entire site began to shape into the comprehensive rocket testing facility it is destined to be when operations commence almost a year from now. In summary, this report period witnessed the accomplishment of an outstanding number of major milestones. The S1C static firing stage was completed and made ready for testing. The first S2 stage battleship firing was successfully conducted, and the assembly of the S2 structural test stage was completed. The first S4B stage for use in dynamic testing was delivered to NASA, and testing was begun. The F1 engine flight rating test program was successfully concluded. The J2 engine demonstrated its restart capability. Vibration testing of the instrument unit got underway, as well as dynamic testing as part of the Saturn 1B vehicle. And new facilities such as the Mississippi Test Facility moved still closer toward the time when they will play their own vital parts in the Saturn V program.